All right, everyone. We're going to go over a couple of the codominance problems that we talked about in the previous video. If you have not watched the previous video where I go over codominance problems, there was an example problem of like red and white, and they're not one does not dominate the other. So there's a capital R and a capital W. And then I went over the different blood types and how a capital I to the A and a capital I to the B don't dominate over each other. So you get AB blood. If this is sounding familiar, great. You're ready to do some practice problems. If this does not sound familiar, you need to go back and watch that video. So let's jump into the online notebook to show you where this stuff is at. Let's get rid of that. Okay, so we're in week 6. And assignment 1 was just to learn about codominance traits. There wasn't really anything you had to do. It was just to learn about it. So again, this is the video that you should have been watching to teach you about codominance problems, to review codominance traits. Okay, and then I give it to you in written form with blood types there as well, but I figured it'd be good to explain it in video. So there's a video. All right, now you should be trying to do some practice problems. So you'll see for assignment number 2, this is where you're actually going to do some practice problems. If this comes out fuzzy, you can click on this link here. There are 6 practice problems here, 1, 2, 3, 4, 5, 6. I'm going to go over numbers 3 and numbers 4. So you can see how these are done, which means you need to do 1 and 2 and 5 and 6 on your own. Okay, so that's what we're going to go over right now, is these practice problems here. And so by the magic of camera, I am going to show you those practice problems in paper form. Okay, so that's the same thing you see on the online notebook. Questions 1 through 6. I'm going to do number 3 and number 4. And I'll do them on a separate sheet of paper here. Okay. All right. Why did I print this out? Why did I spend a piece of paper? Because your learning is that important. So I want to make sure that you get it. This is what we would do if we copied these into our science notebook, is I would teach you how to read the problem and then to annotate it with the right information right off the bat. So we're going to start with number 3. So let's go to number 3. These are my codominance problems. You might be thinking, why are you starting with number 3? The reason I'm starting with number 3 is because number 1 I did in the video basically, and number 2 I think is pretty much out of the video as well. So I'm going to try and help you with the more difficult problems than the easy problems. Okay, a green and yellow feathered parrot. All right, the trickiest part about this is the parrot is both green and yellow. That little "and" there makes a big difference. This is where the English language kind of like screws you up a little bit. So right off the get-go, I realized there's 2 colors, and a parrot can be both colors at the same time. So I'm already thinking this is a codominant problem. The second sentence says, if the feathered color alleles for these parrots are codominant, so that has been confirmed, it is codominant. What are the expected phenotypic ratios of the offspring? Okay, so I go back to this. So I know they're codominant, so I'm going to have 2 different capital letters. So what am I going to choose? Let's just make it easy. Capital G for green, capital Y for yellow. Easy. Okay, and so what do I do over here? I identify my letters, of course. Capital G, capital Y. G is for green, Y is for yellow. We're dealing with parrots. I don't know. Put a beak. Okay, with another parrot. There you go. It doesn't matter as long as you know those are parrots. All right, so now we need to go, what are the letters for these parrots? Let me zoom in a little bit on you guys here. All right, so one of them is green and yellow. So that means he's got a green and a yellow. So I'm going to give that one right here, 1 green, 1 yellow. Is crossed with a green feathered parrot. Okay, so the only way you can have green is if both of them are green, because if one of them is green, one of them is yellow, it's green and yellow. And if it's Y and Y, then they're both yellow. So the only way to be green is to be GG. Great. All right. What are the phenotypes of the children or the offspring? Okay, so we don't know. So question mark. So when it's question mark children, we go to Punnett square, put this genotype here, put this genotype here, GG, GY, GG, GY. Okay, So then I know I don't care about the genotypes, but I need the genotypes to figure out the phenotypes. So for genotype, I got 2GG right there. And I got 2GY right there. So that then tells me the phenotypes. If you're G and G, you're going to be green. And if you're G and Y, you're going to be green and yellow. So maybe yellow wings, green body, or maybe you got stripes, maybe you got dots on you. Who knows? It's green and yellow. So go back to answer the question. That's step 5. What are the expected phenotypic ratios? It's a 2-to-2 ratio, or 50% chance of being green, 50% chance of being green and yellow. Because 2 out of 4 is 50%. There you go. That's the answer number 3. Piece of cake. Oh, you can't see that. There you go. Now it's a piece of cake because you can see the answer. Okay, so that would be my answer right there. If I want to make a super, super awesome answer, I would say there is a 50% chance of green parrots and green and yellow parrots. If I really want to spell it out in complete sentences. All right, that's number 3. So let's go on to number 4. Okay, back to the problems that we have here. Number 4. A woman has type A blood and a man has type B blood. Determine the genotypes of the parents. So I want to know the parents. And what did the parents do? They produced a large number of children. What that means is that there's a lot. So these ratios are pretty much going to be what you're going to see. 50% were AB, 50% were type A. Notice that they're not telling you anything about the letters here. We're going to see that as we play out. So what I do, identify my letters. I'm dealing with blood type, so I know I just go straight to the ones that are given for me. Boom, 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 boom. Capital I to A makes type A blood. Capital I to B makes type B blood. Lowercase I makes type O. All right, I got a woman. Oh, and a dad. And let's go back and find information. The woman has type A blood. So I'm going to put the phenotypes in this time because that's going to keep me straight. And dad was type B. They had a whole bunch of children, and the children were 50% type A. So we'll say 50% type, not type A, type AB, and 50% type A. Okay, 50% type A. All right, so I got that in picture form. So you might be saying, oh, how do we do this? Well, some people will try to do this in your head. I see it when they give me percentages like this. I'm like, hey, those are percentages I could put into a Punnett square. So I'm actually going to do a reverse Punnett square. I'm like, what the heck is that, Maestro? You'll see. All right. So normally I put mom on the outside, dad on top. But I'm actually going to start with the kids on the inside. And so what I'm going to do is I'm going to say, okay, 50% of them were AB. I know there's only one way to get AB blood is to have one A, capital I to the A, one capital I to B. So I'm going to say that 50% of them had that. And to make them 50%, it's 2 out of 4 boxes. So I know 2 of the boxes must have been that. What about the other children? Well, they're type A. So I know that they have to have at least that. And it can't be I to the B. It's either capital I to the A with another capital I to the A or lowercase I. I don't know what that second letter is. It's either that or that. So then we go, okay, let's work backwards. You've done this in math class where you fill in and you figure out the ones on the top. Same concept here. So I know that both the person on the top and the bottom have an I to the A. So that makes this I to the A. And this has an I to the A and this has an I to the A. So something in common, so they must be I to the A. Does that work? Yes, this must be mom. Mom is type A. So this must be mom. Great. Then I go sideways. What do I find in both boxes? Well, it's not, they both have I to the A and I to the B, but I put the I to the A up, so the B must be the one going to the left. So I to the B. And now we're looking at these two things. Well, I don't know which one it is. I don't know if it's a capital I to the A or a lowercase I. So I'm going to kind of leave that a little blank for right now. So let's do some thinking. If I put I to the B right here, would it work? Yes. And would that work for dad? Type B blood? Yes. Okay. If I put an I to the A right here, would that work? You go, yes, it would work for these. But look, that would make dad AB. Dad is not AB. Dad is just B. So that does not work for dad. So this is not a possibility. So the only possibility is the lowercase I. And so that must be dad's blood. I to the B, lowercase I. And so then we go back to the problem and we say, all right, what did you want to know? Determine the genotypes of the parents. Boom, they're right there. Mom is I to the A, I to the A. That's her genotype, or letters. Dad is I to the B, I. Again, why do I know that? Because if this was I to the A to make that capital I to the A, capital I to the A, then that would make dad A and B, and dad is not A or B, he's only B. So that capital I to the A doesn't work. If I put another I to the B here just to show you the other options, sure, that works for dad. Dad would be type B. But then that would make this AB, AB, and we'd have 100% of the children being AB. That didn't happen. So that is not a possibility. So out of these three, the only one that works is the lowercase I. The I to the A didn't work, the I to the B didn't work, only the lowercase I works. So that makes dad right there. That's your answer for number 4. Again, not so much with the doing as much as it is the thinking and working from the children backwards. Sometimes you got to work from the children backwards. Sometimes you work from the parents down to the children. Depends on what the problem is trying to figure out. Okay, that's number 3. That's number 4. Done. So you still need to do, well, 1 and 2, I think you're going to be able to roll through. 5 and 6 may be a little bit difficult. If you run into difficulties with these, again, reach out to me on Jupiter message. Come to office hours on Wednesdays and Thursdays at 2 o'clock, or shoot me a text message. And if you're like really stuck, just take a picture of where you're at and say, I'm stuck right here. Take a picture, text it to me and say, I'm stuck with what to do next. I could text that back to you real easy, not a problem at all. All right? Just don't give up. You can do it. Just believe in yourself. All right, with that, we're done with codominance problems. On to sex linked problems, which is a whole nother little twist that we're going to have going on. All right, everybody, have a good one.